Students, today we are going to start our industrial electronics lab. So here you can see our experiment number 1 is half wave rectifier circuit. This is basically to study half wave rectifier circuit using diode. You just write half wave rectifier circuit using diode, that you have to write. So this is the circuit. So basically half wave and full wave rectifier are the basic rectifier circuits which can be constructed using diodes. You have done already in your basic electronics. This is not the core of power electronics or industrial electronics. The basic electronics part you have done the half wave and full wave rectifier circuit. So before starting the power devices, experiments with power devices, we will just see, or we will just recall those half wave and full wave rectifier circuits using diodes which we have studied earlier. So after that we will carry forward with our power devices, right? So this is our half wave rectifier circuit. Today we are going to perform this half wave rectifier circuit using diode, PN junction diode. Okay, this is our experiment kit where we are going to perform the various experiments using power devices. Various power devices are there: SCR, MOSFET, IGBT, UJT, PUT, diac and triac. This all are thyristor family, right? This all belongs to thyristor family. So there are DC supplies available here from 5 volt to 35 volt. Here 0 and 18 volt and 15 volt. Two AC supplies are there. This is a pot, that means our variable resistance potentiometer up to 1 mega ohm. These are capacitances of various values, and these are inductor, and these are 3 diodes available here, 1 and 4007. Diodes you may use from here also, or capacitances, resistances you may use from here also, or else you can use the external diodes also, or capacitances also. So here we have used an external diode, and we are taking the power supply from here. You can take the wire like this jumper wire and use these capacitances or diodes also while experiments, while you are going to perform the experiments. Here is a resistance of various values. 47E means ohm, 47 ohm, 120 ohm, 270 ohm, 2K, 1K and 1K 10 watt, 1K 1 watt. So you have to just select this selector switch. This is the RL, that means load resistance. So whatever load resistance you are taking, you can adjust this from changing this knob. There is also SCR. 4 SCRs are there, which is of 2P4M assembly. This is a SCR. These also are SCRs, and other power devices are also available here as I have shown. This is the pulse transformer triggering circuit. All these components are together assembled in this whole kit. So we are going to perform the experiments in this kit. So today we are going to just perform or recall the experiment which is about the half wave rectifier using PN junction diode. So basically the main application of PN junction diode is to rectify the circuits. So it is basically a conversion of AC signal to DC power supplies, right? So the diode rectifier gives an alternating voltage which pulsates in accordance with time. So basically two primary methods of diode rectifications are there. We have studied, as I have just told you few minutes ago, the half wave rectifier and another is full wave rectifier, right? So what is a half wave rectifier? In a half wave rectifier, actually one half of each AC input cycle is rectified, right? When the PN junction diode is in forward bias, it gives a little resistance, and when it is in reversing the bias, it provides a provides a higher resistance. So while it is in forward bias, in the positive half cycle we will get a output current, right? So the half wave rectifier has both positive and negative half cycles, but during the positive half cycle the current will flow from positive to negative, right? From positive to negative, which will generate only a positive half cycle of AC supply when it is applied to the transformer. But in the negative half cycle, the current will flow from negative to positive and the diode will be in reverse bias. Thus at the output side we will not get any current, right? A small amount of reverse current will flow during the reverse bias due to minority carriers, but that will be very negligible. So only we will get the output current in forward bias, not in the reverse bias. That's why it is a half wave rectifier circuit, right? So this is the circuit, this is the diode, here 15 volt I have taken, 0 it is connected to, so 0 it is connected to load resistance, one terminal of load resistance, 0 is connected to one terminal of load resistance is here, and this is of 1K, we have taken 1K, and anode is connected to plus 15, right? This is 15 volt AC, so anode is connected to plus 15, that means anode is connected to plus 15, and another terminal of load resistance is connected to cathode. Load resistance terminal, another terminal, it is connected to, using this wire, it is connected to cathode, right? Thus the circuit is very simple, no extra clumsiness here. So this is the whole circuit. We have taken the DSO probe to check the output. One is to check, there are two channels I have taken. One channel is for checking the output of rectification, and another is to see the reference input signal. So these both are here. So while this circuit is completed, after giving this 15 volt AC supply, just turn on this kit likewise, and you will see the output here, and you can predict the output parameters from here. Just click to measure and display all. You have to on this, turn on this, and see the various readings. Vmax is 1.92 volt, Vmin 80 millivolt, and VPP 2 volt. All the parameters are here. And this is for the reference input signal. So no need to take the readings from reference input signal, just take the readings from for only the rectification circuit from channel 1, right? So what you have to do is write in the proper way your lab manual. So first of all you have to write the aim, which is the half wave rectifier circuit using diode, which is already we have studied earlier in our basic electronics, but we are just recalling this basic circuits before using some power diode or power devices. So before using those power devices, we will see the half wave rectification circuit using a PN junction diode. So aim is half wave rectifier circuit using PN junction diode. Then apparatus, whatever we have used Here from this circuit you have to write the apparatus, load resistance, diode 1 and 4007, AC power supply 0 to 15 volt, and wires, multimeters or DSO, whatever you need. And then you have to write the theory part of half wave rectifier circuit, the working of this circuit, then the advantages, disadvantages, and some characteristics of half wave rectifier circuit, like ripple factor is there, and form factor is there, rectifier efficiency is there. So all those things you have to write in the theory part. Advantages of rectifier, half wave rectifier circuit, disadvantages of half wave rectifier circuit, and some applications of half wave rectifier circuit, right? So before that you have to draw the circuit diagram, and you have to trace the or draw the output from this display of DSO, and analyze the output as I have shown the various parameters, and then write down the conclusion. This will be your experiment number 1. So prepare accordingly and submit by the next week. Thank you.